Hello viewers, so we have this question that says glycerol is sold in drugstores as glycerine and is commonly found in soaps and shampoos. What is the molar mass of glycerol? What is the mass in grams of 1 mole of glycerol? How many molecules are in 1 mole of glycerol? And how many grams are in 0.217 moles of glycerol? So the first part is talking about the molar mass of glycerol. Now, how do we find the molar mass of a substance? The first thing we should understand is how to define molar mass. What is this molar mass? So when you talk about molar mass of a substance, we're just talking about mass in grams of 1 mole of that substance. So the molar mass of a substance is the mass in grams of 1 mole of that substance. Yes, so that's what we call the molar mass. Now, where do we find these molar masses? The molar masses are there on the periodic table. So let's take, for instance, if we have an element X, so let's call this element X, and for this X on top there, we'll say we have two values connected to it. Let's say the first value is 12.011 and the second value is 6. So let's have that element having that representation. Now, when you look at these two values here, you find that one of them is smaller and the other one is bigger. In this case, 6 is the smaller value and 12.011 is basically the bigger value. Now, between these two, we have what we call the atomic number. The smaller value that is connected to this element is what we call the atomic number. It's a value that represents the number of protons in the nucleus of that element. Then we have the bigger number. The bigger number is what we call the mass number. This mass number is a representation of the sum of protons and neutrons in the nucleus of that element. So in other words, we are saying when you add protons to neutrons in the nucleus of an element, you are going to find your mass number. Now, this same mass number here is basically the molar mass of an element on the periodic table. So the molar mass on the periodic table can be found by checking the bigger value connected to the element symbol on the periodic table. So in this case, 6 is the atomic number and 12.011, this is the molar mass of one atom of this element X here, is an example that we have given. So what we should know is this can be written in any format. The 12 can be down, the 6 can be up, or rather they can write them sideways, or no matter the arrangement of these two values, just not say the bigger value is what we call the mass number, and that's the molar mass of a compound or element on the periodic table. We're talking about elements, so that's the molar mass of the element, and the smaller value is basically the atomic number. So our main concentration is on the molar mass, which is the bigger value there. Now, what is represented on the periodic table are atoms of elements. This is just representing a single atom of an element. So if we have more than one atom, it means we are going to multiply that number of atoms by the molar mass of that element in order to get the molar mass for that number of atoms that we have. Now, let's go ahead and see how we can find our molar mass for glycerol. So the chemical formula for glycerol is given as C₃H₈ and O₃, like that. So that's the chemical formula we're given. You can see it here in the question. We're given it there. So this is the chemical formula we're given. Now, in this formula we're given here, we can see that we have oxygen, we have hydrogen, and the carbon. We have three elements in this compound. Oxygen has got a 3 attached to it down there. Hydrogen has got 8, and the carbon has got 3. Now, these values that are given to these elements here are what we call subscripts. So these are subscripts and they represent the number of atoms that element has in that compound. So in this compound, oxygen has got 3 atoms, hydrogen has got 8, and the carbon has got 3 atoms. So these are very important because they also help us find the molar mass. So let's go ahead and do that. So we'll say for oxygen, we have it there, hydrogen, we put it that side, and we have the last one, which is carbon. Now, we have 3 oxygen atoms. So we have 3 oxygen atoms, then we have 8 hydrogen atoms, and we have 3 carbon atoms. Now, these values are going to multiply by the mass numbers or the molar masses of these single elements we have there. So you check on the periodic table, you find the molar mass for oxygen, the bigger value, as we illustrated on the other side, the bigger value that is connected to oxygen is what you are going to multiply by 3. You do the same to hydrogen and also to carbon. So let's quickly do that. So what we have here is 3 multiplied by the molar mass for oxygen on the periodic table is 15.999, and this is having the units of grams per mole. And then for hydrogen is 1.008. Yes, let me just rewrite that properly. Yes, 008, and this is also in the units of grams per mole. And then for carbon, we have 12.011. So we have 12.011 grams per mole is the molar mass for 1 atom of carbon. So on the other side, we're going to find the answers after multiplying. So when I do 3 multiplied by 15.999, this is giving me a value that is, according to my calculator, we have 47.997. So we have 47.997. This is also in the units of grams per mole. Then on hydrogen here, I'm finding 8.064. So this is also in the same units of grams per mole. And then for carbon, I'm finding 36.033 grams more as well. So this implies to say what we have now, these values we have here after multiplying, these are the values that we have as molar masses of these elements in this compound. So for oxygen, we have 47.997, 8.064 for hydrogen, and 36.033 grams per mole for carbon. So after doing that, the next step is we need to add what we have here. So we need to add 47.997 to 8.064 and then add it to 36.033. And what we are going to find is basically what we are looking for, the molar mass for glycerol. So when we do that, my calculator is giving me 92.094. And this had the units of grams per mole, like that. So it implies to say what we have here is basically the molar mass of glycerol. So that's the molar mass of glycerol that we have in this compound. Yes. So let's proceed and go to the next one. The next one is saying, what is the mass in grams of 1 mole of glycerol? What is the mass in grams of 1 mole of glycerol? How do we find the mass in grams of 1 mole of glycerol? We just need to understand what molar mass is. We said molar mass is the mass in grams of 1 mole of a substance. So this substance can be an element, this substance can be a compound, this substance can be a molecule. So 1 mole of a compound had the same mass as its molar mass. So 1 mole of each compound, it can be a compound, an element, or any other substance. 1 mole of that substance is having a mass that is equal to its molar mass. So in other words, 1 mole of any substance will have its mass in grams to be equal to its molar mass. So having that information, it means we understand to say the mass in grams of 1 mole of glycerol is still going to be equal to its molar mass. Yes. So we are going to have our answer for this one to be the same as the molar mass. The only difference is the molar mass is in grams per mole, and then the mass will be just in grams. So this is our answer for B. B didn't require us to do any mathematics, but just understanding the concept of molar mass. The mass in grams of 1 mole of any substance is equal to its molar mass. For example, if we have carbon to have a molar mass on the periodic table of 4.011 grams per mole, that's its mass in 1 mole. All right. So that's how that one is solved. We can proceed to the next one. So let's go to C. C is saying how many molecules are in 1 mole of glycerol. So just how many molecules are in 1 mole of glycerol. Now, 1 mole of any substance contains 6.022 times 10 to the power of 23 particles. Now, these particles we are talking about here include things like molecules. These are the particles we are referring to. Molecules, ions, atoms. So when we say 1 mole of a substance contains 6.022 times 10 to the power of 23 particles, the particles we are referring to are molecules, ions, and atoms in that format. Yes. So this is what we call the Avogadro's constant. This value here is what is called the Avogadro's constant. Yes. So what is this Avogadro's constant or Avogadro number? This is the number that shows how many particles are in 1 mole of a substance. And that number of particles is 6.022 times 10 to the power of 23 particles. Now, this is the value that helps us convert between molecules, ions, and atoms. Moles, molecules, ions, and atoms. The Avogadro number. So 1 mole of any substance, in this case we have 1 mole of glycerol. So 1 mole of glycerol is basically having this same number of particles, which is 6.022 times 10 to the power of 23 particles. Now the particles we're talking about is molecules in this case. So our answer is 6.022 times 10 to the power of 23 molecules. So in other words, in order for you to convert from moles to molecules, you just need to multiply by the Avogadro number. So since we are given 1 mole of a substance, we'll say 1 mole multiplied by, now the conversion is 1 mole of any substance has got 6.022 times 10 to the power of 23. Now, the particles we're talking about here are molecules. So we are going to say molecules like that. So more and more will cancel, and 1 multiplied by that value is going to give us the same value. So it means that's basically our answer for this one. So we have 6.022 times 10 to the power of 23 molecules in 1 mole of glycerol. Yes. All right, so we can go to D. Now, D is saying how many grams are in 0.217 moles of glycerol. So we are looking for grams that are found in 0.217 moles of this same substance. Now, when you talk about grams, we're just talking about the mass that is found in this number of moles we're given. So the formula we need for this one is number of moles represented by small letter n is equal to small letter m representing mass divided by the capital letter M representing molar mass. So what we have here is the n, small letter n represents number of moles, small letter m represents the mass, and then the m here, capital letter M, represents molar mass. Now, what we are given there is number of moles. The number of moles represented by N here. And then we are looking for mass. We already know the molar mass because we are just from calculating it in the first part, which is part A. So we are looking for the mass, meaning we can make the mass the subject, and then to find that mass, we are going to multiply the molar mass by the number of moles. So let's do that. So what we are saying is making M the subject, we cross multiply, and what we are going to have is M is equal to N multiplied by M, which is the molar mass. And the number of moles we are given is 0.217 moles. And this must multiply by the molar mass that we calculated is 92.094. And this is having the units of grams per mole. Now from here you can see that the unit of mole and mole will cancel, and then our answer will have the units of grams, which are here. The remaining units will be the units of grams. So let's quickly punch our calculators. When we do that, my calculator is giving me a value that is 19.98. So 19.98 grams is the value that I'm getting. This implies to say that's our answer for the last part, which is 19.98 grams. And the first part, we had 92.094, and the unit for this one is grams per mole. So those are our answers for this question, and that's it for this video. Don't forget to subscribe